All right, so today in Algebra 2, we're going to start section 1.1. Our chapter 1 essential question: what are the ways in which functions can be used to represent and solve problems involving quantities? So section 1.1, key features of functions. 1.1 essential question: how do graphs and equations reveal information about a relationship between two quantities? After section 1.1, you should be able to interpret key features of linear, quadratic, and absolute value functions given an equation or a graph. Okay. So yesterday in class, we reviewed linear, quadratic, and absolute functions. We will spend 2 days on section 1.1. So today and tomorrow, we will finish section 1.1. And at the end of the week, we will take our quiz over section 1.1. All right, so let's go ahead and get started. So the very first question, it says, a diver is going through ocean search and rescue training. The graph shows the relationship between her depth and the time in seconds since starting her dive. So we see this is our picture down here. So our very first question, what details can you determine about the dive from the coordinates of the point 5, -8? So let's look at that point, 5, -8, right here. So it's asking what details can we determine about that? Well, what do we know about the dive at that point? We see that our diver started up here, went down, stopped here, and then started going back up. So that point, 5, -8, we can see that's the lowest point of the dive. So this is our lowest point of the dive. At 5, -8, which means, so what do the 5 and the -8 stand for? So we see that the x's, those are our times, and the y's, that's the depth in feet. And so we know that the diver reached the lowest point of the dive at 5 seconds after starting to dive. And since it's a -8, went down below the surface and 8 feet below the surface. So that's what that point 5, -8 represents. It's the lowest point of the dive, and we know that occurred 5 seconds after starting the dive and 8 feet below the surface. So number 2 says, what is the average speed of the diver in the water, and how can you tell this from the graph? Okay, so average speed, okay, of the diver in the water. This is asking us for slope. So if we look, let's just pick 2 points. We have lines. We know that we can find the slope of the line given 2 points, right? So if I looked at this first point right here, our starting point, so that is the point 0, 2. And then just pick another point, okay? So I have this point right here, 1, 0 is also on my graph. So 1, 0, that's also on that line. So if I look at that, I can either plug into my slope formula that we talked about yesterday in class, y2 minus y1 over x2 minus x1, or remember slope is rise over run, okay? So how far from the first point do we have to go down and over or up and over? So we have to go down 2 and over 1. So we know that we have an average of 2, and this is, we're going down y, so that's feet, over 1, which is time, so seconds. So our average speed of the diver is 2 feet per second, okay? On the left-hand side, when they're diving down, it's a -2 feet per second, and then when they start coming back up, it's going to be a positive 2 feet per second, okay? And number 3, which point on the graph shows the starting location of the diver, and explain? Well, where did they start out at? This point right here. So the point 0, 2 shows the starting location of the diver. How do I know that? Because my time is 0. So that's where the dive begins. Right, our last question with this picture. What does the V shape of the graph tell you about the dive? And then what information does it not tell you? Okay, so the V shape, we can see that the diver started out going down and then came back up. So we know that the diver dove down and then back up. The V shape tells us that. Okay. The V shape of the graph does not tell me if the diver went horizontal. So a V shape does not give me any horizontal movement, right? It's just down and up. All right, so now let's talk about some vocabulary. We talked about some of this yesterday. The set of all possible inputs for a relation is called the domain. This is what we put in. The set of all possible outputs for a relation is called the range. That's what we get back out. Now we're going to talk about notation. So the first type we're going to talk about is called set builder. So set builder notation uses a verbal description or an inequality to describe numbers. Then we also have interval notation. And this represents a set of real numbers by the pair of values. And interval notation is the one that we will use mainly in this class. Okay, next page. In interval notation, parentheses are used when the number is not included in the domain, where brackets are used when the numbers are included in the domain. When we are dealing with infinity, so negative infinity and positive infinity are always in parentheses. Okay? Because infinity, okay, we don't have an actual number, okay? That's like a variable that's representing that. So that's always going to be parentheses because that's not ever going to be included. It just means that it goes on and on and on forever. So here I gave you some examples of what we're talking about. Interval notation, I have bracket, 3, 4, bracket. In words, that's telling me all real numbers that are greater than or equal to 3 and less than or equal to 4 are included. So the numbers 3 and 4 are included. Set notation, we have these set notation brackets. X, that tells me what variable we're dealing with, and then we have this line that tells me, okay, now what is the domain? And then we see that X is between 3 and 4, but it shows me that they are included because it has equal signs. In next type, we have a parenthesis 3, 4 brackets. So this in words, all real numbers that are greater than 3 and less than or equal to 4. So the number 3 itself is not included, but everything bigger than that, so 3.00001, 3.2, 3.5, those are included. The number 4 is included. Set notation, we see the variable is x, and we see the x is between 3 and 4, with 4 being included. So we could say x is x is greater than 3, but less than or equal to 4. And then we could have also written this as bracket 3, 4 parentheses, which means that 4 is not included, but every number up to that, okay, so the number 3 is included, 3.9999999, as we're getting very, very close to 4, that's included. So all real numbers that are greater than or equal to 3 and less than 4. Set notation, the variable is x. X is greater than or equal to 3 and less than 4. So let's put all of this knowledge to work. Okay, so our first example. What are the domain and the range of the function defined by y equals x squared minus 3? And I provided you with a graph. Let's just hit on a few things that we talked about yesterday. So x squared, this is a quadratic. We talked about this yesterday. The name of the graph is a parabola. It's a U shape. Right? Domain, that's all the x values, everything I can put in it. Remember that we read a graph from left to right, The arrows on the ends tell me that it goes on and on and on forever. So domain, we always start with the lowest number first. This arrow tells me that my x's keep going on and on and on forever. So this graph is going to keep extending, so I can put in any negative number. It's going to keep going out to negative infinity. Negative infinity is always a parenthesis, so parenthesis negative infinity, comma. Now I want the biggest x value that I can put into this function. Again, so as I'm going left to right, I see arrow, that means it's going on and on and on forever in this direction, so I can put in any positive number, so I can go to positive infinity. So an interval notation, that's negative infinity to positive infinity, also known as all real numbers. With all real numbers, I could also use this notation. So now we're going to look at what is the range. Remember, these are my y values. Again, we always start with the lowest number, the smallest number. So I look at what's the smallest y value on my u, on my parabola. It's this point. That's a -3. It's on the line, so that's a bracket. So bracket, -3, comma. Now at my y values, I see that my graph is opening up. It's going on and on and on forever. So I know that my biggest y value would be infinity. Infinity never has a bracket, so parentheses. So there's my range. Bracket, -3 to infinity, parentheses. So that's how we look at a graph and determine domain and range. You always start with the lowest number and then end with the highest number. Domain are x's, range are y's. So now example number 2. An air tanker flies over forest fires and drops water at a constant rate, okay, so constant rate, until its tank is empty. What are the domain and range of the function that represents the volume of water the air tanker can drop in x seconds? The picture, we don't have a graph, but it tells me that it releases water at a rate of 400 gallons per second and that the tank capacity is 8,000 gallons. So let's think about our domain, right? So our domain, that's how much water we have, right? We're talking about water that we're releasing per second, right? So our domain is how much, our domain is the time that it's going to take to release all of the water. So our range is how much water we have, right? We see right here we have 8,000 gallons, okay? So we have up to 8,000 gallons. We need to think about, can I have negative, okay? So if we're going to fill this tank, can I fill a tank with negative amount of gallons? No. So we know there will be no negative number of gallons, right? We can't have negative amount of something. So we know that x and y both have to be greater than or equal to 0. So my domain, I have 8,000 gallons. It releases 400 gallons per second. So what's the time that we're looking at here? So if we take 8,000, so to find my domain, 8,000 divided by 400, that tells me 20 seconds. In 20 seconds, this air tanker can completely empty its tank. So my domain starts at 0 seconds and goes up to 20 seconds. Both are included, so brackets, 0, 20 brackets. And that's my time. Those are in seconds. Our range, that's how much water, right, it holds. So again, I know that I can, if my tank is empty, that's 0. So bracket 0, because I can have an empty tank, up to how much does it hold? 8,000. So 8,000 brackets. Again, this is seconds and this is gallons. Okay. So that's how we can determine our domain and range, even if they didn't give me the function, but they told me everything I needed to know, and they didn't give me a graph. Right, so now it just says what are the domain and range of each function and put it in interval notation. So now they're going to give us the equation, but no graph to look at. Okay, so we're going to talk about everything that we discussed yesterday when we reviewed. So number 1, y equals the absolute value of x minus 4. Okay, absolute value. So remember, what did we talk about yesterday? We know that this graph is going to be a V shape, right? Domain, remember, these are what we can put in. Remember, we said absolute value. we can put any number that we want to into an absolute value equation, right? So that's negative infinity to positive infinity. So parentheses, negative infinity, positive infinity, parentheses, or I could write all reals. So now the range, this is what I get back, okay? Remember that in an absolute value, we said that we will never have a negative number. So the smallest number that I could get out of this absolute value would be 0. I can get a 0, right? So if I put a 4 in for x, 4 minus 4 is 0. The absolute value of 0 is 0. So 0 is included, bracket, up to any positive infinity. So there's my range. All right, so now number 2, y equals 6x minus 2x squared. Notice this one is not written in standard form. So standard form means our highest exponent comes first. This is the same thing as saying y equals negative 2x squared plus 6x. X squared, this is telling me it's a quadratic, which means it's a parabola. If I want to find my domain, okay, a parabola, quadratic. Remember the U shape? We had one of those up here. What did we say? We can put anything in it that we want, right? We're not restricted. So my domain, what I'm putting in, all real numbers, negative infinity to positive infinity. My range, again, going back up here looking at parabola, remember my range, if my parabola opens up, I'm going to have a low point. If my parabola opens down, I'm going to have a high point. That point, remember we talked about yesterday, that's our vertex. So I need the y value of this graph's vertex. They didn't give me a graph, but that's okay. I can still find it. Again, we talked yesterday about the formula for the vertex is x equals negative b divided by 2a. Again, we rewrote this problem in standard form so I could identify a and b. Okay, a is always the number in front of x squared, so here my a is negative 2. My b is always the number in front of x, so in this problem my b is 6. I'm going to plug these into this equation. X equals negative b. My b was 6, so negative 6. You just change the sign of it. Divided by 2 times a, my a is negative 2. So I have negative 6 over 2 times negative 4. Two negatives make a positive. That reduces down. They both have a 2 in common. That reduces to 3/2. So the x value of my vertex is 3/2. So I know my vertex is going to be 3/2 something. I'm looking for range. Range are y values. So now I need to find the y value that goes with that vertex. That's going to be that low point. I do that by plugging this x value in. So I'm going to plug this x value into this equation. Solve for y. So I'm going to have y equals negative 2. Instead of x, I'm going to put 3/2. Quantity squared. Plus 6 times instead of x, 3/2. Now we're going to work out what we have here. Notice we have fractions. Those of you that had me last year know I love fractions. We deal with fractions all the time in this class. Okay? So now I have y equals negative 2 to square a fraction. I square the top, I square the bottom. So 3 squared on top gives me 9. 2 squared on the bottom, 4. Plus here I want to multiply 6 times 3/2. So I can do 6 times 3 is 18 over 2. So now I'm still need to work this out. Negative 2 times 9/4. I could go ahead and multiply negative 2 times 9 and then simplify, or I see I have negative 2 on top, a 4 on the bottom. Remember, numerators and denominators, you can cancel each other out. That 2 goes in here twice. So now I have negative 9/2 on plus 18 divided by 2 is 9. So now I need to get a common denominator in order to add these together. So negative 9/2 plus 18/2, right? They now have the same denominator, so I can add them. Negative 9 plus 18 is 9. My denominator is half. So my y value is 9/2. So the vertex, or the low point of this graph, if we were to graph it, would have been the point 3/2, 9/2. I'm looking for my range. So my smallest y value is 9/2. Okay. Or sorry, not my smallest. This is going to be my biggest y value. Another thing we talked about, my a is negative, so this parabola is opening down. Sorry about that. So my biggest y value is going to be 9/2, so that means my smallest y value is negative infinity. So negative infinity up to 9/2. 9/2 is included, so bracket. Okay. So that's how we would do a domain and range when we're not given a graph, but we're given the equations. All right, let's go to our next page. Again, we're going to talk about some vocabulary that hopefully is not new to us. So first we're going to talk about an x-intercept. An x-intercept is the x-coordinate of a point where a graph intersects the x-axis. A y-intercept is the y-coordinate of a point where the graph intersects the y-axis. So let's look at this example. It tells me a car starts its journey with a full tank of gas. The equation y equals 16 minus 0.05x relates the number of gallons of gas y left in the tank to the number of miles the car has traveled x. What are the x and y intercepts of the graph, and what do they represent about the situation? So in this class, you're going to find out we have to identify what is it referring to, what does it represent, okay? So they gave us the graph over here. Okay, so we want to go ahead and find our x-intercept. Remember, x-intercept, okay, that's where it crosses the x-axis. So we come down here and look at the x-axis. Where is our line going to stop? Right here, 320, right? So my x-intercept is 320. If I had to write that as an ordered pair, that would be 320, 0. So on an x-intercept, your y value will always be 0. What does that represent now? So tell me, what does this represent? So we see down here, this is distance traveled in miles. So this represents that the car can travel 320 miles. My y value is 0. What does y represent? The gallons of gas I have, okay? So I can travel 320 miles before it runs out of gas. So now we're going to look at the y-intercept. So where is this line going to cross the y-axis? At this point right here, 16. If I wanted to write that as an ordered pair, 0, 16. So a y-intercept, your x will always be 0. What does that represent? This is gas remaining, okay? This is my starting point. So this means that the car has 16 gallons of gas at the beginning of trip. So at the beginning of the trip. So that's what our x and y intercepts represent. I start out with 16 gallons. I can drive 320 miles before I run out of gas. Okay. All right, so now we're going to practice how do we find the x and the y intercepts of the function when we're not given a graph. We're going to do this algebraically. Okay, you should have done this in Algebra 1, so this would be a review. So algebraically, in order to find an x-intercept, remember x-intercept means my y is 0. So we put 0 in for y and solve. To find a y-intercept, remember my x is 0, so put 0 in for x and then solve. So number 1, y equals the absolute value of x minus 3. If I want to find my x-intercept, I'm going to put 0 in for y. So 0 equals the absolute value of x minus 3. I want to solve this equation to get the x all by itself. So first thing I need to do is move that 3 to the other side. So add 3 to both sides. So 3 equals the absolute value of x. So now what did we say? Absolute value. Absolute value means I can put anything in. So I just know that it's always going to come out positive. So I can say the absolute value, okay, of x, when will it equal 3? X was either positive or negative 3. Okay. So my x-intercepts, I have 3, 0 and negative 3, 0. So now I want to find my y-intercepts. Y-intercepts, I put 0 in for x. So y equals the absolute value of 0 minus 3. What's the absolute value of 0? 0. 0 minus 3 is negative 3. So my y-intercept is negative 3. 0, negative 3. So these are my x and y intercepts. Number 2, g of x equals 4 minus x squared. So x squared, this is a quadratic, which means it would be a parabola or a u-shape. To find my x-intercepts, again, I put 0 in for y, or g of x, means the same thing. So 0 equals 4 minus x squared. I'm going to solve this equation to get x all by itself. I have a negative x squared, so I'm going to move my x squared to the other side, and I get x squared equals 4. I have to get rid of x squared to make it just x, so the opposite of squaring a number is taking the square root. I put the square root into the problem, so remember, anytime you put the square root in the problem, you have two answers, a positive and a negative. So I have x equals positive and negative. The square root of 4 is 2. So my x-intercepts, negative 2 comma 0 and 2 comma 0. Now I'm going to find my y-intercept, so I'm going to put 0 in for x. So I have y equals 4 minus, instead of x, I'm going to put 0 squared. 0 squared is still 0. 4 minus 0 is 4. So y-intercept is 4. So the point 0 comma 4. All right, next it says the x-intercepts are also known as the zero of a function. So there are lots of names for x-intercepts. X-intercepts are known as zeros. They're also known as roots. We'll talk about that later. So just know that if they ask you to find the zero of a function, they're just asking you for the x-intercept, okay? It's called that because they are the input values that result in the function output value of 0. So if they ask you to find the 0, they're saying when y is equal to 0, what's the x value? All right, that's where we're going to stop for today. Tomorrow we will finish these notes. Okay? So your homework assignment is not due tomorrow because we have not finished all of the notes. But you want to go ahead and get started on your homework. Go through and do the problems that you know how to do after today's lesson so that tomorrow you don't have a lot of homework to do. All right, so that's day 1 of section 1.1.